Hi everyone, Dr. Tom McNamara back again for our course in Prep for College Math. I thought I would go over a neat little model for visualizing how and why carrying and borrowing works in addition and subtraction. And the model I like to use is called the chip model. So we imagine we have various trays for each of our place values, the ones place, the tens place, the hundreds place. If we dealt with bigger numbers, we would have a tray for the thousands place, and so on down the line. So each chip that I put in here will represent 1 unit, each chip that I put in here will represent 10 units, so each chip here counts for 10 of these. One of these means 10 of these. And each chip here would represent 100 units, or 10 of these. Okay? So let's start out with a fairly simple addition problem that we'll visualize using the chip model. Let's do 134 plus, I don't know, 23. Okay, very easy to visualize an addition like this in the chip model. We load each of the numbers into the chip model. We start with 134 with 1 chip in the hundreds place, 3 chips in the tens place, and 4 chips in the ones place. And then we are going to add 23. Okay, so we're going to add 2 chips into the tens place, and then we're going to add 1, 2, 3 chips into the ones place. And we can see by this we have 1 in the hundreds place, 1, 2, 3, 4, 5 in the tens place, and finally 1, 2, 3, 4, 5, 6, 7 in the ones place. Alright, things become a little more interesting in the chip model if we try something like this. Let's say I had 278 plus 65. Okay, 278 plus 65. So we start by loading this into the chip model. 1, 2, 3, 4, 5, 6, 7. So 2 in the hundreds tray, 7 in the ones tray. 1, 2, 3, 4, 5, 6, 7, 8, and 8 in the ones tray. And then we're going to load in this second number here, which is 65. So 1, 2, 3, 4, 5, 6 goes into this tray. And then 1, 2, 3, 4, 5 goes into this tray. And now this is where we're going to start trading some things in. Okay, I want a maximum of 9 chips in these various trays. Okay, as you can see right here, I've got 4, 8, 12, 13 in my ones place. I can't put a 13 here, right? In our place value system, we have to use digits that go from 0 to 9. So the biggest thing I can put in the ones place is 9. Okay? So let me see what I've got here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 chips here. What I'm going to do is I'm going to take 10 of these chips and I am going to trade them in for 1 tens chip. Okay? So those guys are gone. I took 10 of these and I traded them in for 1 of these. So I'm doing a little better. Now I have 3 things in the ones place. Now I'm looking over here, okay? And I see I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 chips here. That's too many. Remember, I'm allowed a maximum of 9. But the idea is 10 of these chips in the tens tray is equal to 1 of these chips. So I will count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll take these 10 chips and I will cash them in for 1 chip in the hundreds tray. And now we can see our answer there, 1, 2, 3, 4 in the tens tray, and 3 in the hundreds tray. Okay, And if you think about how this carrying goes in addition, right, this added up to 13. Okay, well we can't put a 13 in the ones place, so we trade 10 of those in for one of these. That's why we carry over 1 to the tens place. And now we have 8, 14. Okay, that's too many to put in the tens place. We can do a maximum of 9. So we can trade 10 of those for 1 in the hundreds place, giving us the 3 right there. Okay? So the chip model gives a really nice illustration of why carrying works the way that it does. And it's also fairly helpful as we get into subtraction. Of course, we're not going to be adding chips if we do subtraction in the chip model. We are going to be taking chips away. So, for example, if I were to do 178 minus 35, I'll start out the same way as if I was using the chip model to do an addition problem. I will load in 178. I load in 178, and now of course I'm not going to put in additional chips. We're not doing an addition problem anymore. We're doing a subtraction problem. So I'm going to take away chips. I'll take away 5 chips from the ones tray. Get rid of these. Get rid of 5 there. I'll take away 3 chips from the tens tray. And we can see easily here that 178 minus 35 is 143. Okay? Nothing difficult there. Let's look at another one. And this is where the chip model can really be helpful. $314 minus 65. So I'm going to start the same way I did just a moment ago. 1, 2, 3, 100. 1 in the tens place. 1, 2, 3, 4 in the ones place. Okay. Now I'm going to start taking chips away because we're doing that subtraction problem. So from the ones tray, I should take away 5 chips. Right away you see I'm in trouble. I don't have 5 chips to take away. I've only got 4 chips. How am I going to take away 5 chips when I've only got 4? Well, what I'm going to do is I'm going to trade in this chip in the tens tray for 10 chips in the ones tray. Remember, 10 of these equals 1 of these. So if you cash 1 of these out, you can get 10 of those. Okay, now the idea here was take away 5. 1, 2, 3, 4, 5. Okay, now I'm supposed to take away 6 chips from the tens tray. Well, once again, I'm in a similar situation. I do not have 6 chips in this tray. In fact, I don't have any chips in that tray at all. So what I'm going to do is I'm going to cash in one of my hundreds chips for 10 chips in the tens tray. And now I can take away 6 of those chips. And we can see right here, what am I left with? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 right there. 1, 2, 3, 4. And 2. Okay? I'm left with 249. Okay, now if we were to execute this in the standard pencil and paper algorithm, we can make sense of cashing in these chips with the idea of borrowing. You got a 4 in the ones place, you got to take away 5. You can't do 4 take away 5. You don't have enough. So you cash in this, now that's a 0, so that you have 14, which is what we had before I took away the 5, right? There were 10 here that I cashed in, plus the 4 that I originally had for 14. Now you take away 5, what are you left with? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Now, you cashed in the 1 that you had in the tens place to get 14 over here so you could subtract your 5. You don't have anything left here. You got a 0, so you can't take away 6 from 0, so what do? Well, you borrow again. You cash in one of the hundreds for 10 of these. Now you got 10, take away 6, leaving you with 4. That's the exact thing that we did right here. I cashed in one of my hundreds chips, got 10 chips here, took away 6, I'm left with 4. And finally, after we do that, we're only left with 2 here. So you can see where we're getting that 249. Okay? So, I don't recommend you use the chip model every single time you have to do a problem. But it does give us a nice visualization of why the standard pencil and paper algorithm for addition and subtraction works the way it does. And as you're going through this course, you should be thinking about how can we make math make sense. Okay? There are reasons for the rules that we use. There's reasons that we do carrying and borrowing the way that we do them. And in this case, the reason is, well, we have this place value system, and if we're doing a subtraction like this, we're doing 4 take away 5. Well, we can't take away 5 if we only got 4, so we cash in one of the tens chips to give us 14 chips in the tens tray, and now we can take away 5 chips if we got 14, and we're left with 9. And then we go down the line there, continuing in that way. Okay, so a nice visualization. Maybe you haven't seen it before. Maybe it helps you understand why these operations work the way they do.